In this page, we'll be talking about periodic trends. So right now, the current element arrangement in the periodic table was developed by Russian chemist Dmitry Mendeleev. Now we want to know, how did he arrange them? What properties of elements did he use to arrange them in a table? And what patterns are there? So one pattern is with groups and periods. Now in the periodic table, groups 1A through 12A, and there's 3B through 8B, and there's periods 1 through 7. Now, whatever period an element is in is how many shells it has in its electron configuration. So since rubidium is in period 5, rubidium will have 5 shells when you draw it out, its electron configuration. Now, with the exception of transition metals, lanthanoids, and actinoids, whatever group an element is in determines how many valence electrons that it has. For example, nitrogen is in group 5b, so it has 5 electrons. Now, another way that the elements are grouped is by atomic radius. Now, the radius of an atom increases as you go down the table. An element in period 1 will have an atomic radius smaller than an element in period 7. Also, as you move to the right of the table, their atomic radius decreases. Now, after that, there's electron affinity. Now, that is the energy released when a neutral atom as a gas gets another electron to make an anion. The lower down you go in a group, the more electron affinity decreases. As you go right in a period, the more the electron affinity increases. But, that's not it. Of course, there are exceptions. Now, the elements among nonmetals in the first period have electron affinities that are actually below 0. Also, there are a couple different types of elements that because they have a certain type of electron configuration, they are usually not stable, and they will also have an electron affinity that is negative, because for the most part they are unstable. After that, the last thing we'll be talking about is first ionization energy, which is the energy needed to release the outermost electron out of a neutral atom in its natural state. Now this decreases as you go down a group, because the outermost shell is much easier to get rid of. The outermost electron is much easier to get rid of because the electrons are farther away from the nucleus, so not as strongly attached. It also increases as you go across the table, going right in each period, because as you go right in a period, the atoms are smaller, and the valence electrons are closer to the nucleus, so they need more energy to remove them because they have a stronger attraction to the nucleus.